Welcome to implementing product security through a flexible bill of materials or BOM structure. I'm Bob Aiello. I'm a CM, ALM, and DevOps consultant. I've been doing this type of work for many years. I'm the author of Configuration Management Best Practices, Practical Methods that Work in the Real World. I'm currently heading up the IEEE P828 Configuration Management Working Group, which is considering real-world issues such as product security in configuration management and flexible BOM structures using agile and lean practices. I recently led the effort to write the IEEE 2675 DevOps industry standard, focusing on building highly secure and reliable systems. I'm a DevOps CM architect and engineer, and I'm very much tools and process agnostic. So what exactly do we mean by a bill of materials or BOM? One definition from the IEEE's well-known CVOCAB online dictionary is a documented formal hierarchical tabulation of the physical assemblies, subassemblies, and components needed to fabricate a product. EIA 649C talks about a product structure, a hierarchical view of the composition, relationships, and quantities of a product and its components. Related term they say is bill of material, drawing list, drawing tree, hierarchy, indentured drawing list, indentured listing, indentured parts list, product tree, pyramid, specification tree, and top-down breakdown. Well, I think we need to break down that definition. So a BOM is indeed a list of ingredients. It's appropriate to call it a recipe. It's actually a list of parts. It is very much the structure of what you're building. It's comprehensive, but one of the things we have to consider is just how much detail do you really want in a BOM? And more importantly, is there more than one kind of BOM? So in practice, we often talk about a design BOM, an engineering BOM, a manufacturing BOM. They should really all be the same, but in truth, a lot of times there's a difference between the product as it's envisioned in the design, engineered, and actually manufactured. And a lot of the differences between the engineering BOM and the manufacturing BOM come down to the realities of product manufacturing. Sometimes parts are not available, sometimes requirements change, and we have to be able to respond to those change. Another type of BOM is the SBOM, or the software bill of materials, and we'll talk a little bit more about that when we get to firmware. So in some sense, BOMs are in the eye, are really in the view of the beholder. So contract manufacturers, a supplier in China might look at the BOM a certain way. And for localization reasons, a supplier in the Philippines might look at the same BOM a little differently. So the suppliers have to work with the contract manufacturers to actually deliver the product. But what if the prices change drastically, impacting supply and availability? What if a contract manufacturer, the supplier really, what if they run low on capacity or parts? So we have to understand the problem in order to be able to deal with it. A key consideration is the complexity around BOMs. We often do not know what goes into our BOM, even though we really think we do. BOMs change due to shifting requirements and manufacturing constraints. How many levels deep do we go? We want to think that we understand the bill of materials end to end, but in practice, there's often a lot of complexity in there. And we have to consider the fact that at a certain point, we reach what we call a baseline, or actually we mark a point in time for a potentially shippable product. So baselines, once improved, the baseline should be honored. A lot of times there are regulatory considerations. It's not always so easy to change the baseline once it's been approved, and baselines have to be verifiable. So once you say that you're going to ship a product and the bill of materials and the structure is determined to be a certain way, if you get approval for that, it's not so easy to change that at the last minute. But does that mean the BOMs are really immutable? In practice, the idea of an immutable BOM is kind of an illusion. The reality is we like to think that once we've gone through the effort to define a BOM, it will not change. In practice, BOMs often do change. And one of the goals of our talk today is how to manage that type of BOM. How do we acknowledge the fact that BOMs have to change and we have to be flexible? How do we use the right principles in agile as well as lean so that we produce secure and reliable products, but realize the reality is a lot of times things change way beyond our control. So the question is whether the change impacts the form, fit, or function of the parent configuration items. So if we change something at a child level because a particular part's not available, we have to consider what's the impact on the parts above it. There might not be any impact. So we have the concept of interchangeability. And this is straight out of EIA 649C, the Configuration Management Standard. When a part within a product is changed and re-identified, the rule is to re-identify the next higher assembly and all subsequent higher assemblies up to the level at which interchangeability is reestablished, or an identifiable end product against which configuration changes are tracked is reached. So let me translate that to English for you. If I change a child part and there's really no impact on the parent, I don't need to uprev or increase the revision number of the parent because from the parent's point of view, the child products are all interchangeable. So there's no real impact from a customer view. The product, even though some of the child parts may be a little different, they come from different suppliers or a particular um, child part is no longer available. The product, for all practical purposes, has the same form, fit, and function and works the same. So that's the concept of interchangeability. And it's a reality, even though a lot of times we try to think that, the bombs are really not going to change. In reality, they often do. So let's try to understand effectivity, which describes this experience of having parts for a particular product that we ship that may be different out there in the wild, and customers are not bringing their products back in just to get them uh, you know changed up to be the exact same. We may have the same product out, and it may have the basic function be the same form, fit, and function, but deep down some of the child parts are different. So effectivity is a designation defining the product range, for example, serial numbers, block numbers, batch numbers, lot numbers, model dates, or event at which a specific product configuration applies. A change is to be or has been affected, or to which a variance applies. Now, variance is a key concept in understanding effectivity. So by variance, we mean a departure from the approved product definition, information for a limited amount of time or for a specified effectivity that does not require a revision of approved product definition information. This is all from EIA 649C, the Configuration Management Standard that's well known. So a good example in practice, and let me try to give you kind of a specific example and make this a little clearer. I might have firmware, right? I might have some firmware that runs on a particular device. And with software, we often use what's called semantic versioning. We have major, minor, and bug fix. And if I have a change to a bug fix, and sometimes we call that a patch, it might really have very little impact on the parent device. The example that I often give is maybe I figured out my algorithm a little better or a bug in my algorithm, and if I tweak it a bit, I'll get 15 minutes more battery life. So every product that I ship from this point forward, I'm going to ship with the new firmware because I want my customers to get the best possible battery life, but they're not going to bring their products back in for me to update the firmware. If it's an IoT device, I might be able to push the changes down, but a lot of times I've sold a device to a customer and they're not bringing it back in, and that's okay. We have some variants out in the field. The products basically work the same, but some customers, happy them, they get a 15 minutes more in their battery life, and that's a good thing. But that is the reality of the way that a lot of this actually does work. So we have to consider that. So in firmware, a major change could impact form fit or function. A minor change could kind of go either way. So we have to consider whether or not a change in firmware actually has an impact to the parent, and whether or not that could cause us to have to change the revision number of the parent assembly. So let's consider some of the factors that impact that change. So some of the factors that impact could be cost, quality, time to market, demand and supply. We have to consider these factors because they are the reality of making any product. Cost could become so great that we'd have to raise the cost or price of a product, and making it really inaccessible to some of our customers. Could impact the quality. We might find that some of the parts have quality issues, and so we look for another part that is better quality. That again, that doesn't necessarily mean we're going to call back all of the product that we've already sold, because it may be within acceptable limits of what we promised, but new versions of that product going out might have some variance in what we're actually shipping. Time to market is important. There could be demand and supply issues with parts, so that if we um, just insist on getting a particular version of a part, it might slow down our ability to deliver product. And a lot of old school engineers will say, well, that's just life. You're going to have to accept that. Well, it's not always so easy, because there are times in which we have to consider special factors, and we'll talk about that in just a moment. So, one of the things we always want to do is learn from our mistakes. If there are issues with the product we ship, we have to consider incidents occur, which when we fail to account for dependencies, we should look at that as a feedback loop. For example, if there are security issues, we may want to update our firmware. We may want to update some of the parts to be able to make the product more reliable and secure. Remember, a chain is only as strong as its weakest link. So when one part of the assembly is compromised, that could be an interface to other parts. So you really want to consider the whole product in terms of security and the impact to the overall product. So we have to look at the whole system and understand if there's a particular vulnerability, how that might impact the whole system. And it might be in terms of security, it might be in terms of reliability and other key issues. So the supply chain itself could also be a source of risk, and we've seen incidents like this recently. The assembly could be a source of risk. The components can be inserted with malware and other vulnerabilities. I've seen this with some of the products that are shipped with PCs, where the particular product actually came with some software or firmware on it, and it turned out there was malware and other vulnerabilities in that product. So it's one thing to consider the forensics. We definitely want to understand what went wrong so that we can improve what we're doing and not have that kind of problem going forward. But forensics can be a little like closing the barn door after the horses are already gone. So you have to balance understanding with what occurred with actually building in security from the very beginning. And this is where things start to get a little more exciting. We have to anticipate problems that may occur before they occur, and consider the bomb as a line of defense. So understanding your bomb in depth is key to understanding your risks and dependencies. Well, how do we do that? In practice, we hold review sessions, we pull in subject matter experts. You may have one expert who knows that battery inside and out, another one who's really good with the firmware and other particular parts. So when you review that bomb structure, you really have to consider who are the folks that have to weigh in and help you understand the whole system. Contract manufacturers and suppliers may be a risk. They may not have the same level of concern that you do. Always assume the worst. Always plan on accepting the fact that there may be some vulnerabilities and you have to be able to assume that you've got to deal with that particular problem. So engineering discipline in bombs is very, very important. Bombs are fundamental building blocks. We have to consider engineering quality, testing, verification and validation, traceability for security, review and approval by regulatory authorities. So when we create our bill of materials and we review it, we really have to consider whether or not we have the right level of quality, whether or not we have the right testing built in, whether or not we've designed these devices to be able to self-evaluate whether or not there are problems and report back if there are. So how do we actually come up with approaches that align with agile and lean practices that help us to be able to be more flexible, but at the same time, focus on product security and reliability? So, first thing to understand is that taking a rigid view of the bill of materials may be unrealistic. That alone may introduce errors and risks that are unacceptable, may be impractical in many practices, impact cost and delivery. So, we have to consider that there's a certain level of rigidity that actually could introduce problems and is just overall unrealistic. So how do we go about this and actually start to build in agile principles in the way we work? So the first thing is we want to consider the customer view. We want to consider what matters to our customers in everything that we do. What are they looking for? It's not just a matter of the product is has the right fitness to what was designed or fitness warranty. We also have to consider, as Duran and Deming and other thought leaders taught us, is what is the fitness for use? What is the right way to consider how the product works, and does it meet the customer need? You have to understand your real world risks and dependencies. If you are relying upon contract manufacturers in different parts of the world, do they have the same level of concern that you do? Could they, in fact, cut corners and ship a product that has either defective parts or perhaps malware on it? There could be problems with the way they manufacture that make that product vulnerable to attack. So you have to understand your real world risks and dependencies and start to consider how you develop your products with the ability to test and monitor for those kinds of issues and be able to react to them. So, one of the key concepts is last responsible moment. A lot of times when we're building, we don't really understand all of our requirements up front. We have to have the product in use a little bit. We have to get further down in the design and construction. So the Papendiks are well known for coining the phrase last responsible moment. And that's the last moment at which it is responsible to make a change. Because a lot of times you don't have all the information that you need up front, and if you give yourself some time with the product and really understand what's going on, you may make better choices as you go down the road. So, some of the agile and lean practices really help us to be more responsive. They help us to obviously be more agile, but in many ways can also help us to produce more reliable and secure products. So, we have to welcome change even at the last minute, but changes the last minute do introduce risk. So we have to make sure we understand our risk. It's not quite just a matter of welcoming change. We have to have a strategy for understanding what change means and how do we actually deal with that. So risk is not inherently bad. I've been in a lot of meetings where we've reviewed products and we ask the engineers, so what's the inherent risk with this product if we make a change or not make a change? And a lot of times everybody gets all nervous in the meeting. They start saying, oh, no, no, there's no risk. We've checked everything out. No, no, that's not what we mean. There's risk in everything we do. If we walk across the street, there's risk. So identifying risk of making a change or risk of not making a change, understanding the risk in using a particular contract manufacturer or supplier, there's always risk. And understanding risk and managing risk well can be very, very rewarding. So, a lot of folks that embrace understanding these factors, they can help the team be very successful and very, very um, profitable in everything they're doing. So we're not saying that you can't have any risk. We're saying we want to understand risk, we want to communicate it to key stakeholders, and manage risk in a realistic way. And if there's anything that's going to help us produce secure and reliable products, it is having that frank discussion of what can go wrong. What is the risk? And a lot of times there's risk of making a change or risk of not making a change. It can go either way. And understanding in practical terms what that risk means, identifying it, having an appropriate plan of action. If in fact you're going to go down a particular path that has some risk, that can help you be very profitable because it allows you to be more flexible. It allows you to embrace change that you cannot prevent. It's just being realistic. But at the same time, having a way to address the sorts of things that come up in product manufacturing every single day. So risk has to be considered based upon the industry that you're in. Now, it's been my personal experience when I'm working with aerospace and defense, they take a very traditional engineering approach. And I'm not saying that's wrong. They focus on security, whatever it takes. Lives are at stake. Uh, I had a discussion with a cherished colleague in the aerospace industry, and we were both online doing a webinar on a very similar topic. And I brought up that sometimes you have to embrace change at the last minute. And he said, "No, we care more about safety." And and I brought an example to him, which I'm going to talk to you about in just a moment, in which if we didn't embrace change at the last minute, lives could be lost. So it's really a misnomer to think that if you take a traditional approach, a waterfall approach, that you're always safe and secure. Sometimes not understanding the situation has its own issues. So let's talk about this. We do care about security and quality. We do care about keeping companies profitable, or they won't be in business to bring us those products that we really want. So a good example is medical devices. And of course, a medical device, well, gee, we want those devices to work, right? We want them to be safe and secure. If a pacemaker's in grandpa's chest, we certainly care a lot about risk. So one of the things that happened was COVID, right? We all understand how that impact occurred. And I, along with other folks, signed up to help with addressing the need for respiratory devices for medical care. And in one of the groups that I was working with, we feared the worst. We feared that we'd need hundreds of thousands of respiratory devices in a very short amount of time. And if we took a very traditional waterfall life cycle and we slowed things up, people could die. We needed a way to create respiratory devices fast, have them still be fully reliable and secure, and also available at a reasonable cost. So we wanted to make respirators as fast as we could, and too much rigidity could result in tragedy. It would be nice we can sit back and say, oh, we have to take our time in creating these devices. But then if 100,000 people don't have the devices they need to stay alive, then our efforts to be safe and secure would be for naught. So sometimes there are urgent matters that really require that we have the right level of care and going slow and careful with agility so that we can produce the products. We needed to get those respiratory devices out there as quick as we could. And, as it turned out, there wasn't as much of a demand for it, fortunately, but that was the kind of choices we had to make. And in fact, in medical devices, you want those devices to be readily available of any kind. You want them to be cost efficient because people can't afford to pay $100,000 for every device. You want them to be economic, and you want companies to stay in business so they can give us these products and services. So let's think about what this means for product engineering. Products by and large enhance and save lives, right? So we have to consider how much security is enough, the cost of the devices. If we make manufacturing infeasible, then people won't have those respiratory devices they need. They won't have the pacemakers they need. They won't be able to get the care they need. So having the right level of care to be able to produce these devices in a timely fashion, you want to make sure that the products are available. This does not mean that we've given up on quality. What it means is we're going to consider inherent risk in everything we do. We're going to consider the cost of what we produce as well as the profit, right? If we get this right, we'll have companies that are very profitable. They'll produce products that consumers need and want, and those companies will be around for a while to be able to serve us, have good jobs for folks, and produce the kind of things that really enhance our lives. So we can't give up on quality. We can't give up on security, but we have to really focus a lot on how do we continuously improve our process. So continuous process improvement is, well, continuous, right? Understand incidents and problems. When bad things happen, that's your opportunity to learn from your mistakes. So I often say never let a good crisis go to waste. Make sure that when things happen, you analyze what happens, you get people to a place where you have a healthy culture, where folks are willing to admit their mistakes, willing to talk about risk. Remember that meeting I told you about, and then the engineer I was working with almost bristled when I said, let's consider risk. He thought I was insulting him. Far from it. Let's consider that customer first approach. How do we take the right level of care, prudent level of care, develop the product that people need, and still continuously improve what we do? So a key part of that is taking a systems view. So I want to understand the full product end to end. That's easier said than done, right? Understanding each component, understanding the folks who actually manufacture it, make sure that I'm including the right stakeholders so that we educate each other and we get as much knowledge as we can out in the open. Silos really impact productivity in a very bad way. If you have a siloed culture that's very dysfunctional, this is where we talk a lot about DevOps, and it's very much relevant to this type of work. We want to make sure that folks are sharing their knowledge, that they're willing to be open, that they're willing to consider what they're doing. And if you're using manufacturers and suppliers, if you're acquiring products or if you're a supplier, you want to make sure that you're willing to share that knowledge and be open to best practices such as the configuration audit, which verifies that what you planned on building actually is what you ended up building and that it meets the required need of your customers. So bombs really are a key way to be able to get there. They're the roadmap. I like to have review sessions with the key stakeholders, go over what's in the bill of materials, help me understand, share your knowledge with me, understand where there's discrepancies between what we designed versus what we manufactured. That is really key. Be able to conduct the configuration audit of the bomb. In other words, is the product actually going to be manufactured as was designed? And is what we manufactured actually meeting the needs of the customers? That's the difference between the physical versus the functional configuration audit. We want to make sure that we are developing products that meet the spec, but also more importantly, that they are fit for use by the folks who are going to use our products. So we also want to build in the ability of the product to self-evaluate. Can the product alert us when there's a problem? Can the product come back and tell us, hey, there's some issue with the device that we've manufactured. Picture a situation where you're creating brakes on a train. You have to build in the capability to identify if there are any issues with the device. A lot of trains these days have a lot of automation. You could have a situation where some aspect of that automation, some aspect of that device could be vulnerable for attack. and a someone who has ill will could actually impact the form, fit, and function of the devices that are piloting the train. So you have to make sure that the equipment is built with self-validation up front and the ability to alert if there is in fact a problem. So we have to consider change. Change is inevitable. You can have change due to competitive pressure. Too often we look at change as being a bad thing. Change happens. And in fact, sometimes there's opportunities in change. If you have an ability to be competitive to produce your products at a better price or include features that you see are out there, uh, embracing change can often be a very positive thing. You have to consider regulatory requirements to report any changes in your design. And most importantly, you have to consider customer feedback. Are your customers happy with your product? Are they happy with the quality? And that is very important to consider. So verification and validation is a key capability. It's a continuous process. Was this device built in such a way that it meets the specifications and with the specifications correct? So verification, we can consider whether or not the product is consistent in the way that it operates and whether or not it actually meets its intended function. So verification and validation, testing, quality management, all of these are part of the continuous process to build in excellence to everything that you produce. You have to anticipate and build in the validation up front. You can't tack it on at the end. You cannot tack on security at the end. If you don't build your devices to self-evaluate and report when there's anomaly, then you're not going to be able to put that on at the end. It's something you really have to consider up front. So automation is really key. It's an absolute must-have. These devices, the ability to self-evaluate must be automated. You have to build products with automation in mind. And I realize that's not often easy to do. A lot of times, the whole process of building the products can be very complicated. You got enough to do to meet the deadline. There's a lot of pressures. There's cost considerations, there's availability, but this is a real must have. You have to consider, what am I going to automate? Can I automate the ability to have the device self-check, the configuration audit? There's the physical configuration audit and the functional configuration audit. Does the product actually physically meet its intended and designed requirements? And does it meet the intended use of the folks who are going to be using it? And most importantly, do we have an ability to monitor and alert when things are not exactly the way we think they should be? So DevOps has really made this very, very popular. And I've just headed up the effort for the 2675 IEEE standard for DevOps, building reliable and secure systems, including application build, package, and deployment. The link to that standard is right there. This is one of the things we really do have to consider, is many different best practices in that we could have a whole nother session on, but this is very much relevant to what we're talking about. And then I invite you to join me in the IEEE P828 working group, in which we are creating a new version of the IEEE standard for configuration management in systems and software engineering. That's the link right there. And I'll give you my email address in just a moment. But in considering product security and having flexible BOM structures, the best practices are out there. We know how to do this. We know how to create reliable and secure systems. We know how to create systems that can self-detect and alert us if there are issues or problems. So it really remains upon us to be able to utilize these best practices, to utilize feedback loops, to consider the reality not just live in an ivory tower, but understand things change. We have to embrace that change and be able to produce high quality products. So that's my email address, bob.aiello@ieee.org, and my LinkedIn. If you do try to link with me on LinkedIn, please tell me you saw this video so that I know that I should accept your LinkedIn invitation. And I encourage you to be in touch and share your best practices as well as we consider product security and flexible BOM structure, and we move configuration management to new heights to be able to achieve our goals. Thank you very much. Bye-bye.